Welcome back. During Severe Weather Awareness Week, we talked about how climate change is negatively impacting severe weather events. Meteorologist Dana Fulton has a deeper dive into the conversation.
A search for climate records starts with the National Climate Extremes Committee.
We protect that data, make sure it's available for generations to come, and people can get to it and understand it.
Deke Art is the chair of the committee. Under him is an archive of hundreds of years of global climate records.
So when you're sitting on top of the world's history of climate information, you can kind of take today, what's going on today, and put it in perspective of what we have seen in the past and what we expect in the future.
And the data he's looking through, it shows a trend. Temperatures are rising.
And that's due to increased greenhouse gases, trapping heat near the surface of the earth. Wisconsin, like a lot of North America, it's cool season and its overnight periods are warming more quickly than the warm season and the daytime period.
Harold Brooks with the National Severe Storms Laboratory is on the same page.
And it's because of the increase of greenhouse gases in the atmosphere due to the burning of fossil fuels. And there's not really a question about that.
The question lies in the impact. What does a warmer world actually mean? And how is it connected with severe weather forecasting? A few degree difference on an average Tuesday might not sound like much, but temperatures are one of the variables for severe weather, and not just heat waves. Warmer air holds more moisture. It brings bigger rain. It will fuel larger, more impactful severe weather events. The trend of average temperatures increasing is not good.
But we really don't care that much about the average conditions. We care about the combinations.
The combinations lead us in a cloudy future, one where we're not exactly sure of the ties to severe weather because of all of the variables.
It's tougher to just observe changes in severe weather, much less connect them to climate change. There is not nearly as clear a signal or a known relationship between severe weather as there is with maybe big heat, big rain, or big drought. But without being able to tie a bow around it and call it settled science on the violent weather part, I have personally, as a professional in this business, that seeing the bigger events farther north in colder times of the year, I think that speaks to the availability of the instability and the fuel and the warmth and the humidity that are needed to power those.
We have sort of a Goldilocks problem. We have a balancing problem taking place that, will the ones that increase be more important than the ones that decrease as we go into the future?
If you're still having a hard time wrapping your mind around the variables of a severe thunderstorm, think of a storm like a football team. We'll call them the Wisconsin Tornadoes. Each of the players impacts the strength of the team, just like each of the variables impacts the strength of a severe thunderstorm. The quarterback is instability, the offensive line warmth, the running back temperature change, and wind shear the quarterback. Now, climate change is impacting these variables, so some of them continue to grow while others are shrinking. With variables growing and shrinking, it's just like if a player's having a rock star season while another is battling injuries. The variables make it difficult to plan out how the season will go, and these changing variables with our climate also make it difficult to paint a perfect picture of our future.
The inconsistencies are already playing out. The December 2021 and March 2022 tornadoes in Wisconsin are prime examples.
We look sort of from November through February, those tornado days have become much more likely to be a really big day than they were just 40 or 50 years ago.
It's about more than severe thunderstorms and tornadoes. As I just mentioned, warmer air can hold more moisture. Extreme flooding is also becoming more common, like August 2018 in Wisconsin.
In Wisconsin, that has ramifications for flooding, for creeks, rivers. You guys have a lot of water up there to begin with.
Your roads, your drainage systems, your crops respond differently to those kinds of situations. And so how we deal with increasing extremes in weather is a very difficult challenge for us as individuals and as a population.
As a population, it's important for people to understand how this has an impact on all of us.
I know some people like to say when we look back at the data, the reason that we're seeing all these changes and more information is because of technology and the fact that we have better resources to actually record the weather. How do you account for that?
Well, those are called inhomogeneities in our kind of data world. It's when the observing system changed, or the way that we observe things, or the technology changed, or the emphasis changed. And we are certainly, just because we're better forecasters, we're better at validating tornadoes in particular. The things that we're most confident in are obviously the things that we observe the best, and those are temperature and precipitation.
Temperature and precipitation, two of the primary variables for severe weather. Changes in both will certainly impact severe weather in Wisconsin.
The reality is it's changing, and it has consequences.
That's meteorologist Dana Fulton reporting. For other top headlines this week and your local election results, head online to channel3000.com. Thanks for joining me today. Enjoy your week.
This has been For the Record.